We're in Tucson, Arizona. Not bad for November. Let's get into MQTT. HTTP communication feels really cumbersome when you try to make an IoT device. MQTT was designed for IoT. It's lightweight, which isn't really clear what that means until you try putting it on ESP32 and seeing how much faster it performs. And also, the two-way communication aspect makes it ideal for complex systems that are meant to talk to each other. This is the first video in a series on MQTT. Let's just start off by getting you your first MQTT broker. I'm going to talk about a few things I like about MQTT, then let's get into setting it up. We'll do that both for your laptop and on a Raspberry Pi. With a Raspberry Pi, it's actually easier. You can establish your MQTT broker with just 5 lines at the command line. It's simple, but once you get there, it doesn't mean you really understand the configuration in a way that you could build an effective system. I'm going to try to go one level deeper than the typical MQTT get started video and help you understand what's happening in the background so you can effectively start building up your project. From my experience, your project development is actually easier with MQTT. When you have these two devices that need to talk to each other with HTTP, you've got an outgoing request that gets a response. You either have to have that device sitting there with an operating server, or you've got to mock it up in your development to make sure your first device even works. With MQTT, they don't need to know about each other. Both devices can just be connected to the MQTT broker. Let's say in this setup, I get them both connected. My ESP32 is going to publish temperature and the Raspberry Pi is going to read that temperature. While I'm developing, I can just work on the ESP32. I'll connect it to the broker and publish. This will work. It doesn't care that the Raspberry Pi might not be there. Same goes when we're working on the Pi. It doesn't need to receive those publications to work without error. We don't have to have two systems running to develop one. We can develop them independently, then put them together and confirm that they work. Addressing your projects is easier as well. If you're using HTTP and the layout looks like this, each of your devices has an IP address and a port. For one device to talk to 2 others, it needs to know its IP addresses and ports. If that changes, you've got to reprogram your device. With MQTT, that washes away. There is a broker with an address and a port, but that's all you need to know. This Pi can simply publish to a topic, and that ESP32 can listen to that topic without either device being aware of the other one. Similarly, if we come to the situation like this where there's a remote broker, each device could individually attach to that broker, but then it has to be responsible for TLS. We could also just put another broker in between them and have them connect without TLS and have this connection maintain the TLS. Well, that's not actually different than what can be done with HTTP. But what's different is that we can attach to a system elsewhere that's also behind a firewall and let all of these devices communicate seamlessly. This next part I call flatten flows. Let's say in our project we've got a device publishing T1, a second publishing T2, a third publishing T3, and then a fourth device that's subscribed to all 3 of those. Maybe it pulls that data in and does some transformations on it to get T average and then controls a relay, let's say a furnace. Some of these lines and combinations can get kind of complicated with HTTP, but with MQTT, everything becomes an isolated project. You've got 3 devices that publish and you've got one that's subscribing. The subscriber then manipulates that data, but we can do things differently. We can even include an app in this scheme. The app's sole purpose is to listen to data, transform it, and re-emit it in a new form. That simplifies what devices do. Let's say these 4 devices are attached to a cloud, but are physically located in Los Angeles, or let's say Tucson. We could be pulling data from those devices, transforming it, and sending it back from a Raspberry Pi sitting in your office in Ohio. So devices can be sent around the world, and those devices perform certain jobs, but what the system actually does can be governed by code anywhere else in the world. So where are you going to put your broker? You could put it on your desktop or laptop, a Raspberry Pi, or maybe you put it up in the cloud. We're going to hold off on doing it in the cloud for now. That requires TLS, and also you're probably going to want to have and administer a password file, and it's a little bit too much work for right now. Plan A would be put it on the Raspberry Pi. But if you don't have one, there's nothing wrong with putting it on your desktop or laptop for now, just to see how it works, but you'll probably want it on the Pi eventually. The next question is, how are you going to deploy it? Are you going to install it right onto your device directly, or are you going to use Docker? If you're a Docker user, that's probably preferable. But if you're not in the Docker yet, that's fine. Actually, that's just an extra layer of abstraction, and If you care about performance, having it natively installed may be better anyway. So I need to make a little plan for this series. Today's topic is just Mosquitto installation, and in fact, I'm going to deal just with native installation, so that means on my laptop and Raspberry Pi. After that, next week, we'll get into Docker installation. It's slightly different, but between the two devices, they're pretty much the same. Once you've got your Mosquitto broker going, attaching, publishing, and subscribing and listening, those are things that your devices are going to do. We've got our C++ devices, which means ESP32 for now. And you could also do Node.js devices and apps, which will be either on your Raspberry Pi or in the cloud. But for now, we're doing native installation. And for reference, that means Windows 11 and also Raspberry Pi OS Trixie, which I have not used before. But actually, all of these Mosquitto installations have worked the same regardless of operating system. Let's start with our laptop. Search on Mosquitto and go to the page. It's as easy as it looks. You're going to download, look for the Windows installer, save it, and run it. This file shows up and doesn't delete. I think it's my laptop. I don't think you need to worry about that. Hit yes for everything, and it installs it in C program files. Once you're done, the broker's running. Again, I can't get rid of this file, so I'll just move it off the screen. Let's go into program files. You'll see the Mosquitto folder. Always you want to focus on this mosquitto.conf. That's the main config file that starts everything. But for now, look at this _sub and _pub. This Mosquitto folder is not on the path, but while we're in the folder, we can call those commands to demonstrate that the broker is working. We're going to subscribe to topic hello, then open up another window in this folder, and we're going to publish to topic hello with message, how are you? And you see that the first window got the message. So these two windows are talking to each other, but what we want to do is get ESP32s to talk to each other. So let's go through and look at this mosquitto.conf. If we cat it out, you see it's just a very large file that is completely commented out. The one thing we have to get into now is this listeners command. You see the syntax given here. We call listener with a port number, and then optionally we can give it an IP address or host name. And for now, I got to tell you, what you want to imprint on your brain is listener 1883, allow anonymous true. That is the key to getting any Mosquitto broker going in your basic setup. Right now, you've got Mosquitto spun up on your laptop, and we showed that those two windows, which are on localhost, they worked. What Mosquitto has as default is it's listening on 1883, but the host name is the local host. It only allows traffic on the computer on which it's installed. It also mentions anonymous true so that these two windows, which do not specify username and password, can connect. But you are undoubtedly aspiring to do more than just have communication on your laptop. You're going to want to have your broker attached to some network where devices connect. In order to talk to all the devices on our network, we have to specify that in our listener, which is 0.0.0.0. This will open up our broker to the entire network. However, that line alone will not work. By default, allow anonymous is false, which means you have to have a username and password to connect. So put this line in and set it to true. And by the way, the listener, once you specify it, does default to listening to all the network addresses, so you don't need to specify 0.0.0.0, which gets us to this line I mentioned before, listener 1883, allow anonymous, true. Going back into your Mosquitto folder, let's open up that Mosquitto conf and add those lines. So I'll comment it out, so I'll go to the bottom, listener 1883, allow anonymous, true. Need to save it as admin. Now our broker's set up, but we're on a Windows laptop, so the firewall is there preventing other devices from connecting. We turn this off temporarily, obviously, to get the devices to connect. But what of the devices? We haven't programmed them yet. To get the system to work, we need one device that will attach to Wi-Fi, then attach to the MQTT broker, and then publish messages. The other device has to attach to Wi-Fi MQTT, but then subscribe. I've put together some code that does just that. You can pull down the repo that's listed in the description of this video. We've got a simple publish Arduino sketch and a simple subscribe Arduino sketch. These will work in Arduino IDE on ESP32. Notice that both sketches are not very long. They are oversimplified, but they will work. You'll also notice they're overwhelmingly similar, except for the parts where one publishes and one subscribes and listens. I'm going to attach the simple publish sketch to one of my ESP32s and the simple subscribe to the other, and then let's see if they talk to the broker. Starting with simple publish, I commented everything out. Notice that setup and loop are still there, but everything else is gone. Let's add things one at a time. Let's do Wi-Fi first. Wi-Fi.h, we've got to define an SSID and password. And then let's open up the serial and call Wi-Fi begin, wait for it to connect, and then log that we're connected. Loop's not going to do anything for now. I'll upload this, and we connect to Wi-Fi. Now I'll go back and do the MQTT part. We need pub sub client. That gives us an MQTT client. But the first thing we do is we attach that MQTT client to a Wi-Fi client, meaning up above, Wi-Fi.h establishes the Wi-Fi connection, but Wi-Fi client is a user of that connection. We've got to create the Wi-Fi client so that MQTT can ride on top of that connection. We do that here. Then back above, we've got to say where this broker is at. I've got my values in here already, but how did I know that? On my laptop itself, I put in IP config, and I can see that my IP address on the network is the 192.168.0.64. We can copy and paste that into our code. We're going to stick with a port of 1883. So these values are good to go. Host and port, we come down below and we tell MQTT to attach to our host and port, our broker location. Before we connect, we have to have a client ID. Let's just call it my first publisher. Then down below, we're ready to connect. Unlike Wi-Fi, this waits until you either succeed or fail. So after we call connect, we can just check the status and then print, hopefully, that we're connected. So we upload the code. You see that we connect to Wi-Fi, and then we connect to MQTT. That's as far as we've coded it. Now let's go back and look for the publish part. That's the part that's still grayed out. We'll define an interval and create a timer variable so that we can run the classic scheduling clock down below. Whenever millis minus our timer exceeds the interval, we're going to try to publish. Here's a nice function for you to use, MQTT client.connected. You could check that every time to make sure you're not trying to publish when the connection's actually gone. But if it is, we're going to publish. Ping is the first part, the topic, and the second part is the payload. You probably are already aware that MQTT messages always have a topic and payload. With that gone, we'll log that we published and we'll reset the timer. That set up, we'll compile. The device connects to Wi-Fi, connects to MQTT, and immediately starts sending the pings. Moving on to our simple subscribe, a lot's going to be the same. The Wi-Fi connection, the MQTT connection, they are the same. The only difference is what we do with the MQTT connection. So I'm going to uncomment all of this. We already know it works. We come down to setup as well. Let's just get as far as our MQTT connection. This is all going to work. So the only thing that's left is our subscription part. We are going to subscribe to ping, but before we do that, we're going to set this callback. We're going to tell MQTT when a message comes in, call a message handler. The message handler is defined above. You have to use this pattern for it to work. You've got to define a function that takes a topic and then takes a byte array, not a character array, and a length. You can traverse across this byte array and change the values to characters so that they serial print on your screen or can be copied into a buffer to be processed somewhere else. Once that message handler is established, we subscribe to ping, and then we call client loop. And what this does is it constantly checks for any incoming messages. When they do come in this case only messages of topic ping, the message handler will be called. It's complete, so I'll compile and upload. We connect to Wi-Fi, we connect to MQTT, and now on a 3-second interval, you see this second device is receiving those ping messages from the other ESP32. I don't really like this layout, so I'm going to edit a little bit and re-upload. Connected to MQTT, and okay, there's a little bit better formatting on the message. Topic and payload. So we've got this set up. We've got a Mosquitto broker on our laptop. It's attached to a network, and 2 external ESP32s are talking to each other through that broker. That's a success. Uninstalling Mosquitto takes a little bit of fiddling. When you go to add or remove programs, don't look for Mosquitto, look for Eclipse Mosquitto, starting with an E. You run the uninstaller, but when you go to program files, you see that there's still some remnants there. If I try to remove them, I fail, at least with my command line. But if you go in with Windows Explorer, it does work. Okay, so we've got it off our computer. I've been making videos for a few months. So far, it's been a lot of firmware on the ESP32. We're going to start to transition into the Raspberry Pi and get into other general IoT concepts. If you want to stay apprised of when these videos come out, please subscribe. And also remember, if you do like this content, hitting like helps YouTube know that, and it also helps me. Okay, let's switch over to the Raspberry Pi installation. This is where you're more likely to put your broker anyway. We've got a Pi 4. I guess we're up to Debian Trixie now. Haven't used it. I like to go with the headless installations, the one without the desktop environment. I'm calling this gateway. Username and password won't matter because I already have my SSH keys on there. And I'll go ahead and throw on this updated Wi-Fi password. Save and burn. I'll skip the verification, not so critical right now. I'll get the SSID on this Pi, plug it into the wall, give it a few minutes to attach to the internet, and then we can access it at gateway.local. Now, in the same repo where we've got these 2 sketches that we just burned, we've also got some Pi install scripting. It only takes 5 lines. I mentioned that in the beginning. Let's start with the first 2. We're going to update our Pi, then we're going to install Mosquitto. When that's done, the broker is running already. I always say look for the mosquitto.conf, and when we look here, it is different. It's not that everything is commented out. We're adding a location to persist data between reboots, and we're adding a log file. The Windows version didn't have that. We won't get into the stuff now, but what we want to notice is this include dir. When we cd in and look at the README, it's saying anything you put here is going to get read into the config. And remember, we always want to have listener 1883 and allow anonymous true. That's what these next 2 lines are about. Notice I'm going to write into a file called additional.conf in that conf.d folder. There's our listener 1883 and allow anonymous true. So if we just copy these lines and run them from anywhere, this will establish our required config on our Mosquitto broker. I go in that folder and confirm as much. So now the only thing to do to make that config take hold is to restart the broker. Done. We're ready to go. I haven't put a firewall on here, so it's already exposed. We can attach our devices. But let's get the IP address first. Under WLAN 0, we see that we are at .69. I need to pull back my ESP32s and recode them with the updated IP address. They need to know to go attach to the broker on the Pi, not the Windows laptop. Connected, MQTT connected, and immediately sending the ping. So our publisher has connected. Let's go over to our subscriber and get that updated. .69, burn. Okay, our subscriber is now getting the messages from our publisher, all this going through the Raspberry Pi. So we've completed this picture where we no longer need our Windows laptop. We have a self-sustaining IoT system running. Another success. Uninstalling Mosquitto on the RPi is much easier. I've also got a script for that. You can copy these commands and paste them in, and Mosquitto will be gone. There you go. You've got your first Mosquitto broker. That's all for today. Hopefully now you've got yourself a decent MQTT broker on which you can start building your project. After this, I'm going to get into connecting your devices, whether it's an ESP32, which is C++, or a Raspberry Pi, which will be Node.js, or could be Python. Let's get your different devices connected, then we'll get into how we publish, and then we'll get into how we subscribe and listen. I'm Larry. Have a good week. I'll see you at the next one.